Hello everyone. So I'm here today to tell you how existence works physically. Okay, so let's get to it. Okay, so fundamentally everything is connected within existence by the photon and the antiphoton, okay, which are both encompassed within the Higgs. Okay? So, the way you can think of it is basically the photon, within the center of it are waves. Okay? Magnetic waves. Okay? Shooting infinitely in every direction. Okay? Shooting out, shooting in, going every which direction. Okay? And on the edge of the photon are all the antiphotons. Okay? Basically consuming all of the magnetic waves. Okay? Entropy. Okay, I'll get into the electromagnetic spectrum in a minute, but basically all the waves on the outside are being consumed by antiphotons, okay? Kind of like the sun has its horizon, and then everything is being consumed on the outside by space, okay? Which is the antiphotons, okay? So, and it's all contained within the Higgs, okay? And it all can be considered the infinite torus, okay? Because everything within the photon is infinite, okay? Because you delve into the photon and it just gets to be more and more and more and more and more. It's infinite, okay? Everything within existence is infinite, okay? So, let me get into the electromagnetic spectrum. So, the electromagnetic spectrum is basically just electrical and magnetic waves, okay? So the beginning of it, the wavelength of them is very long. It's the longest that it gets until the very end of the electromagnetic spectrum, where the wavelength is the shortest and the frequency, the oscillations of frequencies, is the highest, okay? So the best way for me to simply illustrate that is to draw it like this. Okay? So that's a rough drawing of it, okay? And it basically, from the electromagnetic spectrum they know right now, okay, it starts at radio, microwave, infrared, light, ultraviolet, X-ray, and gamma, okay? That's basically the current electromagnetic spectrum. 1, 2, 3, 4, 5, 6, 7, okay? But the thing they currently aren't accounting for is the electromagnetic spectrum actually starts at magnetic waves, also known as love waves, which oscillate at 10 to the 0, which is once, okay? Going all the way up the electromagnetic spectrum till the end, which is gravity waves, also known as entropy waves, which oscillate at 10 to infinity. Okay? But 0 and infinity are both a loop. Okay? So they're basically the same thing. Okay? It's like I said before. You have the photon on the inside surrounded by the antiphotons in the outside. The photon on the inside are all these waves going up to here until you get to gravity and entropy, which is the horizon, which is consuming all of them. But whenever you account for the infinite torus, that's infinitely everywhere within the photon. Okay? It's infinite. It's all beyond infinite. Okay? So, give me 1 second and I'll be right back. Okay, so like I was saying before, the electromagnetic spectrum. So, whenever you're accounting for the electromagnetic spectrum and the photons, antiphotons, and Higgs, it's all basically just photons that are the largest at magnetic and love waves going down to the end of the spectrum, which is gravity and entropy waves that are infinitely small. Okay? So, let me get into the gradius of space. Okay? So the gradius of space, which means step in Latin, is basically just the steps, okay, between the photons. Okay? It's basically just going up a stairway, down a stairway, getting infinitely smaller, infinitely larger in every direction. Okay? That's how the universe works. Okay? It's all beyond infinite. Okay? So those are the gradiuses of space. Now let me explain the fields of time. Okay? I had to add in fields of time because it was confusing saying, well, different things are in different gradiuses because everything's pretty much infinite. Okay? The fields of time are infinite, the gradiuses are infinite, photons, antiphotons, Higgs, toruses, they're all beyond infinite. Okay? So the fields of time. Okay, so let me explain this. So for instance, a hummingbird. Okay? A hummingbird's heart rate is over 1,000 times a minute. Okay? A turtle's heart rate is like 6 times a minute. Okay? So, although me compared to the hummingbird, I can see the hummingbird and everything like that, and it can see me, but it's in a much faster field of time than I'm in. Okay? So compared to it, we probably look like turtles, okay? Just barely moving around compared to them. You know what I mean? And to them, they probably just think of themselves as kind of like regular birds, you know? And a turtle probably looks at us like we're like a hummingbird because we're moving around so quickly, okay? There's different fields of time, okay? Like, for instance, people, like you and I right now. I'm basically emitting information to you right now, but you're watching this video. So it's actually in the past. We're not in the same field of time, okay? What you're watching right now is in the past. Those are different fields of time. Just like you might live to be 90 years old, I might only live to be 70 years old. That's a different field of time, okay? And you can kind of judge fields of time depending on heart rate, okay? Because time is relative, okay? Time is the entire electromagnetic spectrum, okay? Time is everything encompassed, okay? So it's relative to the entity that you're comparing. You know what I mean? So for instance, our systems within ours, you know, like the cardiovascular system, the nervous system, skeletal, integumentary, they're all in different fields of time, okay? Because think about it like this. Think about a heartbeat. It's like boom, 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 boom. Well, if you slow that down, boom, 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 boom. See, the circulatory system, our heart, is actually in a faster field of time than our respiratory system, okay? All of our systems within our body are in different fields of time, okay? And that's kind of the way that it works. I'm going to show a video in a little bit that kind of explains that a little bit more to you guys, but our current processors and different things like that for computers and different things like that they're too limited for me to be able to show you a lot of this stuff with trigonometry, graphing, and different things like that, because as we're limited, you know what I mean? But these videos I'm going to show you in a little bit, I'm going to show you, you know, kind of like how you can apply mathematic graphing to the different organ systems, like the heart rate or the alveoli of the lungs, or, you know, just different things like that. And you can apply those to the graphing. And if you had somebody that was a really meticulous person that wanted to basically graph out like a human heart on a graph, and basically play it in fast motion, like getting larger, getting smaller, getting larger, getting smaller, our current computers are limited. You'll know what I'm talking about in a little bit whenever I show the video, but yeah, they're just too limited to be able to show those things. So, but it would be pretty cool though if you could literally draw a heart in a graph and make it beat just like a regular human heart beats. But our current computers and things like that are too limited. They're not even close to having that kind of capability yet. So, but that's the thing about it, is with the photons, the antiphotons, the Higgs, the waves, okay, you can kind of graph this stuff out using sine waves, cosine waves, tangent waves, cosecant waves, secant waves, cotangent waves. You can graph this stuff out, which I'm going to show you guys in a little bit, where you can kind of start seeing things, and it starts making sense mathematically, you know, because I've gotten to the point now just playing around with mathematics and stuff like that I can pretty much prove all this stuff now. So that's what's kind of fun about it, is, you know, it's cool to theorize, but whenever you can actually prove it, that's a whole nother level, you know. So I'm going to show you guys some videos, and I will be back to talk to you in a little bit. Okay, so I want to show you all a little app with some mathematical graphing that I've been working with. So if you're talking about the
photons, antiphotons, all contained within the Higgs, which is the infinite torus, you start to find that the way that they're shaped is, like I was saying, it's kind of like a sphere with basically photons and photons infinitely moving towards the center as well as the horizon and shooting out of the horizon, as well as coming back at the horizon. So if you look at this, basically this graph playing with square roots of numbers, the processor on my phone is kind of limited, so it's still a fast processor, but like I was saying, you know, it's just our current technology is way too limited for all this stuff. So whenever you start looking at this, you can see that these here are far too small. They're in the very center. I would have to scroll into the center quite a ways before you could start to see them because they're so small. But once you get up to about 0.2, yeah, you can start to see them. Okay, and they start moving out. Now, the reason they're moving into the center like that is because they're basically falling into the center infinitely. Okay, they'll just keep getting infinitely smaller and smaller and smaller. Okay. Now, whenever you start coming back out here, you'll see that they start to get less and less curved until straight at 1, and then they start to curve out again. Okay. Okay, so you see them, they're curving, and as you get further out, you start to see that the bottom that are hitting the X and Y axes, they start to square off, okay? And they start to move back in again in the shape of a square. Okay, right here you can see it's like a squircle, and then a squircle is basically a square with edges that are rounded. Okay, like a circle. Okay, and they start to go into square format, and they'll just keep getting smaller and smaller and smaller until you can no longer see them dropping off into infinity. Okay, so if you look at this, you can see on the outside edge up here, it kind of looks like you're looking at a building that just infinitely keeps going up. Okay, it's just like a building that never ends. Okay, and that's kind of like the shape of the infinite torus. Okay, and they lead into it's the outer edge is like a squircle, okay, and it leads in to a square. But the thing about it is, a square is never really a square, because whenever you start to zoom in towards the edge of a square, you'll find after you zoom in far enough that it's no longer straight edged. It gets to be more and more circular. Okay, so within existence, there's no such thing as a perfect square or anything like that. So that's kind of how the infinite torus works. I'll explain it a little bit more. I want to stop this video just because it's getting to be a little bit long. All right. Okay, so once again, looking at the gradiuses of space, once you start, okay, so you zoom out on this, all right, but once you start zooming in, Okay. You can see that it keeps going. And the further in you get, the more square it looks. Okay? But if you kept on zooming in, it basically the squares would just turn into squircles, okay? And it would just go infinitely, okay? But let me press the play button on P real quick and show you what it looks like. Okay, basically right now you're like zooming in on the gradiuses of space. Okay. So let me zoom in a little bit. Okay, that was just one that I wanted to show real quick. Now, using calculus, okay, and with everything sped up exponentially, okay, you can basically see kind of like universe, like I was, I've said it in my other videos, but you can basically kind of see like the universe breathing mathematically, so you just press play, get it going, press play, get it going. Okay, you can see. You know what I mean? So this is basically sped up to negative 100,000 to a positive 100,000 the way that you're watching this right now, okay? So right now you're literally seeing kind of like the universe breathing, like mathematics, okay? So now let's look at sirens, okay? So as you can see this, I think of the two waves that are up there kind of like a couple little sirens, and they'll get infinitely larger and infinitely smaller. Right now it's just based off of negative 1,000 to positive 1,000, okay? But that's basically all you're seeing right now is, I just think about it as a couple little sirens and like, you know what I mean? But that's basically, kind of like the gradiuses of space, everything getting infinitely smaller and infinitely larger, okay? Alveoli, let's look at those. So this is how you can kind of watch mathematics. Just think about this as like an alveoli in the lungs, breathing. You know what I mean? You can literally see this stuff, because that's all everything is basically just mathematics. What I'm showing you right now is just things I've been playing with that kind of shows you that. The only bad thing is, with our current computer processors and different things like that, we're limited on what we can actually watch, okay? So let's watch trigonometry phase life, okay? So this is kind of like, this is trigonometry phase, but it's negative 100 quadrillion to a positive 100 quadrillion sped up. So you can literally see the life and death of the photon and how it applies, because that's basically all we are, is just an accumulation, conglomeration of photons and antiphotons contained within the infinite Higgs. You know, so if you watch this, this is kind of like the same thing that happens to us. Okay, so going really fast, really fast, really fast. Then you watch them slow down to 0, then bam, speeds back up again. Okay, same thing with us. Okay, we're alive, we get old, we slow down, we die, we speed back up again. We're reborn, we speed back up again. And that's basically happening infinitely, you know, beyond infinitely within existence, you know. So that's all you're basically seeing right now, but it's with the use of mathematics, okay? Now, let's look at a heartbeat, okay? So if you had somebody that was a very meticulous person, they could basically pretty much graph a heart and show it working, kind of like I'm showing right now. Like you can see the xy equals p, xy equals negative p. All these are the different, you know, mathematical equations, and it's accounting for the blue is like photons, the red is antiphotons. So if you watch it, you'll see kind of like a heart beating. It was looking better without the my phone using all the extra processing that it's using right now for this video and different things like that. It works better, but it still looks relatively like a heartbeat. Bum 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 bum. Okay, but it looks a little bit better whenever my phone's not using all this excess processing. So let's look at another one, which looks like the rings of Saturn. Okay? So if you basically, it's basically just using sine and cosine, just x plus y to the squared equals p, and negative p, accounting for the photons and antiphotons. You can basically kind of see kind of like the lines of Saturn. You know what I mean? And I mean, that's just a small example, but I'm just showing basically, you know, how everything is pretty much just mathematics and you can figure it out. Another thing, okay, this is probably the deepest thing that I have, is space. Okay. Hopefully this will work with all the processing I'm using on my phone, because I was having a little bit of an issue with it. So to be able to account for existence, like I was saying before, it's basically just photons, antiphotons, you know, contained within the Higgs getting infinitely smaller, infinitely larger. So to account for that, you can basically use sine, cosine, tangent, cosecant, secant, and cotangent waves to basically be able to see everything. So whenever you zoom out, it takes a minute because it's just this, like I said before, you know, our current technology is limited. The processor on this phone is actually very fast, okay, but we're still so limited on our technology that it can't keep up with all the graphing it's having to do right now. So I'll zoom out again. let me stop this video and I'll start another one to try to get everything better situated. Or no, it's zooming out now. So give me 1 second. As you can see, like I was saying before, you can see, you know, the sine, cosine, tangent, cosecant, basically all those waves, and basically the lines are black, but they're broken up so you can account for photons. So whenever I move the P over, if it's going to let me do it. It's just my phone is using so much processing power right now, it's having a hard time keeping up. You know, but that's the thing about existence is, you know, it's all beyond infinite. You know, that's how we all do the things that we do, because we're all beyond infinite. You know, it's once you start accounting for the physics of everything, it's just so intense. It's such a beautiful thing. So let me stop this video. Let me try to get it better organized and see if we can go from there. Okay, so like I was saying before, so the P on this is from -13 to +13, okay? So this is basically kind of like you looking out in space. The further you can see out, you know, you're going to be able to see more and more black holes, okay, that are basically contained within the galaxies, okay? And what are black holes? Well, they're basically just dense conglomerations of antiphotons, okay? So once you zoom in to about 6, you'll notice it starts to look like static that you see on your TV. Okay? Because that's all the cosmic microwave background is, and static on your TV is basically just photons and antiphotons being, you know, shot at you infinitely. You know what I mean? So whenever you start to zoom in further, you'll notice the waves of antiphotons start to take over, okay? Until you get all the way to 0, and then you'll see that it begins to look like space. You see that? I hope you guys can make that out, because that's basically all space is basically antiphotons, photons contained within the Higgs, shooting infinite directions, getting infinitely smaller and infinitely larger, okay? So yeah, like I was saying before, and if you go down further to the negatives, it basically just does the same thing as we just did. It goes from basically what looks like space to looks like static to looks like an accumulation of basically antiphotons and photons, you know? So yeah, it's pretty deep stuff, but it's just cool because we can figure all this stuff up with stuff out now with use of technology and mathematics. You know, it's a beautiful thing. So there's that, and this is something that's kind of cool. I showed it in one of my other videos. So basically, just with the use of basic mathematics, you know, whenever you zoom in, it just looks like a bunch of circles and squares, triangles. But whenever you zoom out, it looks like the middle of a flower. Okay? And that's all that nature is pretty much, you know, mathematics. You know, it's a beautiful thing. So, and then the solar system. Let me look at that real quick. Where did I have that at? There it is. Okay. So, solar system. Okay, so think of this as kind of like our solar system. Okay, I know that the planets and stars and everything like that doesn't orbit perfectly spherical, but I'm just showing this as an example. So, whenever you basically, you can think of this as the Earth. Okay, the middle is the sun. This is the Earth. And whenever you zoom in, you can just keep zooming in, and it'll just keep going. Okay? And that's kind of how existence is. Like I said, it's just basically infinite spheres getting infinitely smaller and infinitely larger. You know what I mean? So that's pretty much the solar system. And then the golden ratio. Okay? I did this the other day, so hopefully I can figure out how to do it again. Where was that at? Well, I might use that in another video or something like that. I think I've pretty much proven my point with this stuff. But the golden ratio comes into play as well. It's a pretty interesting way of looking at things, because this is pretty much like the golden ratio. Okay, and you can see it's all flipping out, flipping in. Now, if I change this to 1,000 pi, yeah, okay, so yeah, so you go back here, get to a certain point. Okay, now if I change this to 10,000 pi, 100,000 pi, okay, you'll notice that instead of being you know, the angles are straight rather than a square. Okay, the higher pi you go. Okay. So you play this, yeah, so you'll see that they basically get, the more pi there are, the straighter they get, okay? $10,000, and then you got yeah, that's limited. But anyway, I was playing with it the other day, and it's just it's pretty intense to see just how the different angles of all of it changes. because it goes from circular to squared off angles and different things like that, which, like I was showing you with the shapes video, it goes from, a squircle to a square, back to a squircle again, and it just, infinitely does that. But the further that you zoom in on the angles, you'll find that there's no such thing as a straight angle. They're all circular angles. So, okay, but I think that's about it. I just wanted to show you guys that. So, all right, thanks.
Okay, so I hope you guys found those videos enlightening, which I'm sure that you did once you see that things can actually be proved mathematically using graphing. But anyway, so I want to talk about Einstein and Planck, okay? So Einstein came up with relativity, which is E equals mc squared. Energy equals mass times the speed of light squared. Planck came up with energy equals Planck's constant times the frequency of oscillations. Okay, so basically, if you account for the electromagnetic spectrum, okay, like I showed before, it's kind of like this. Okay, so you have the wavelength getting larger and the frequency of oscillations getting smaller, okay, going this way. Going this way, the wavelength gets smaller and the frequency of oscillations get larger, okay? So whenever you account for the photon, okay, going towards the center of the photon is basically Planck, okay? Going from the center of the photon to the horizon of the photon is Einstein, okay? And then whenever you get to the horizon of the photon, everything basically reverses, okay? So Planck is going away from the photon. Einstein is going towards the horizon of the photon, okay? They basically swap, okay? Because everything is basically photons and antiphotons contained within the Higgs, okay? That's all basically existence is, okay? It's just waves, okay? It's you can think of this is like, you can think of the photon is like an infinite stream of little sperm that are oscillating every which direction, okay? Getting infinitely larger and infinitely smaller, okay? Because the photon, like I said, is an infinite torus, okay? And everything within the photon is infinite, okay? So right now I'm explaining infinity to you guys and how existence works, okay? Because the current model is, the model before the current model was a steady state, okay? Which basically considered the universe infinite. Now the current model is the Big Bang Theory, which basically surmises that everything came from a Big Bang and bam, everything exploded out. This is basically all those put together, okay? Because there was a Big Bang. The Big Bang did occur in your universe whenever your parents had sex. And you were basically conceived. And then, psh, inflation. And from there you were made, okay? So that's Einstein and Planck and basically how they applied. So now let's get into the elementary forces of physics. Okay? So you have the electromagnetic spectrum, gravity, the weak force, and the strong force. Okay? So let me draw a picture for you guys, kind of showing you the gravities of space and how they work infinitely. Okay? Okay, so like I was saying before, everything basically within existence is beyond infinite, okay? Like, I know they consider that we live in 3 dimensions. We don't really live in 3 dimensions. We live in infinite dimensions, okay? So, hence why I can draw this right now. Okay, so this is kind of like how the gravities of space work, okay? It's basically like a series getting infinitely smaller and infinitely larger, okay? So if you start to connect all the lines on this, actually, you know what? Let me connect the lines and I'll be back in a second to show you how it looks. Okay, so this is basically my attempt at rendering it once you start connecting all the lines, okay? Technically, if the tip of this marker was 0.003 from infinity small, okay? Technically, if I kept filling in the lines, I would just keep filling in the lines basically infinitely. Okay, so that's the thing about it. That's the gravities of space. Okay, they're infinite. We live in infinite dimensions. Okay, and some people say, you know, the universal limit of the universe is the speed of light. Well, even the speed of light technically is infinite. Okay, because whenever it leaves the horizon of the photon, which is infinite, an antiphoton, which is infinite, contained within the Higgs, which is infinite, okay, it is going the speed of light. Okay? But the thing about it is, once it gets to the next field of time, which is basically mass and energy, and it's absorbed, from here to here, it relatively might go the speed of light, which is basically the speed of information. But once it gets to here, it's infinite again, okay? It's absorbed at infinite speeds, okay? So, okay, I was going to get into the electromagnetic spectrum, gravity, the weak force, and the strong force, okay? So as I was showing you with this, the gravities of space, everything is basically infinite, okay? And if you start to really look at it, you'll see it starts to kind of look like static, right? On your TV, that's all it is. That's all static is all you're seeing is basically photons and antiphotons coming at you, and you're infinitely absorbing them, okay? So, I already went over what the electromagnetic spectrum is. Gravity is what I said before. It's basically antiphotons, which are basically entropy waves, okay? Which are basically consuming all the magnetic waves, okay? They're polar opposites, okay? The photon can be considered +1, and the antiphoton can be considered -1, okay? You add +1 and -1 together, you get 0, which is the Higgs. Okay? You times +1 and -1, you get -1, which is the antiphoton. Okay? You times -1 and -1, you get +1, which is the photon. Okay? And that's basically how everything pretty much exists. Okay? So electromagnetic spectrum, gravity. So the weak force and the strong force. Okay? What is the difference between the weak force and the strong force? Okay? Well, I didn't explain this before, but like I said, entropy. For those of you that don't know what entropy is basically, say you have this board, okay? If you sit around and you watch this board for 1 trillion years, okay, you're basically going to watch it turn into dust and decompose, okay? That's what entropy is. It's mass moving towards its most chaotic state, okay? So that's basically how to kind of explain entropy and how it works. Now, the weak force and strong force, okay? So, okay. So, the strong force. The strong force is what holds atoms together, okay? The weak force is kind of like with a nuclear explosion, what allows them to come apart, okay? So the strong force is the strongest force, okay? And then I can't remember, I think then it goes to the electromagnetic spectrum, and then the weak force, and then gravity, okay? And that's how much stronger than they are than each other. I don't have the numbers written down right now, but the strong force compared to gravity is exponentially higher. It's way higher, okay? Way stronger than gravity is, okay? Now, to explain that, all I have to do is tell you that relates to the gradiuses of space, okay? Because the strong force, the electromagnetic force, the weak force, and gravity are basically all the same thing, okay? Because, okay, take this atom for instance, okay? Now, in the middle of the atom, you have the protons and neutrons. On the outside of the atom, you have all the electrons orbiting, okay? So, the best way I can explain it to you is a photon, an antiphoton, the Higgs, an atom, a solar system, existence, they're all the same thing. Just different sizes, okay? They're all the exact same thing, okay? Okay. So what's the best way for me to easily explain that to you guys, okay? So, okay. So, you know how I said this is an atom earlier? Well, now think of it as a galaxy, okay? Within a galaxy, you have a mass of photons and antiphotons in the center. And going out, you have photons and antiphotons, okay? So think about it like this. Think about this is the Earth, this is the moon, okay? This is the sun, okay? So the Earth is basically being orbited by the moon, and the sun is being orbited by the Earth, which is being orbited by the moon, okay? Now, they're all within a black space, which are the antiphotons, okay? So, oh man, it gets difficult to explain the further you delve into it, okay? But the M spectrum, gravity, the weak force, and strong force, they're all the same thing, okay? They're just in different steps of the gradiuses, okay? Like, for instance, you, okay? You are basically an accumulation of photons and antiphotons, which are both infinite, contained within the Higgs, which is infinite. Okay? That's all you are. Okay? So, accounting for the gradiuses of space, an antiphoton is the same thing as a black hole. A photon is the same thing as a star. Okay? So all you are is a conglomeration of stars and black holes. Okay? That's all you are. You're just a conglomeration of stars and black holes. Okay? You are basically a black hole. Okay? Which, going back to the fields of time, okay? So, for instance, everything until it hits me, like all the light, the air, the colors, everything until it hits me, time is going forward. Okay? Let me draw it up here towards my little guy. Time is going forward until it hits me, and then time is going backward. Okay? And you might say, well, how exactly does that work? Well, because everything that you basically experience, you're experiencing it as a memory. Okay? That's the way that time works. Okay? You're basically just a black hole of time. Okay? And you can imagine the future. That's how we come up with new ideas and progress, is through imagination. You know, that's how you see the future, is through imagination. Unless you're dreaming. Whenever you're dreaming, time and space no longer apply. You know what I mean? Whenever you're dreaming, we're all basically connected. That's why dreams are so strange. Okay? So, but that's all you are. You're just a conglomeration of black holes and stars. You know what I mean? And it's a really beautiful thing, you know. people ask where in the mind consciousness originates from. I don't think consciousness is in the mind. I think your brain is your processing unit, and it allows your body to be able to exist, you know, just like your cardiovascular system, your respiratory system, integumentary system, your skeletal system. All that stuff allows you to be able to exist, but that's not where your consciousness is everything that's within you. And you are a conglomeration of photons, antiphotons, and Higgs, which are infinite, which are beyond infinite. Okay? So, you can think of the photon as kind of like a stream of infinite smaller photons and antiphotons flowing through it. Okay? But that's the thing about it is that you're more than just photons, antiphotons, and the Higgs. Okay? Because they're always moving. Do you understand that? So you're more than just the stream of antiphotons, photons, and Higgs flowing. You know what I'm saying? Like you're more than that. It's a beautiful thing. Like for instance, right now, from me to you, okay? So say I take a tomato, okay, which is basically a bunch of spheres, okay? It's just a conglomeration of mass and energy. I eat a tomato, okay? It goes into me. It goes into my digestive system. The spheres are broken down smaller and smaller and smaller, okay? Like I said before, photons getting infinitely larger and infinitely smaller, okay? They're broken down. They go into my circulatory system, my urinary system, all that stuff like that. They're broken down more and more and more and more and more until finally they get to my Higgs, okay? The horizon of my Higgs, where they are consumed by my antiphotons, which are entropy waves, okay? Gravity waves, okay? Which are basically holding me together, okay? And then what happens again? Well, they start to get infinitely larger again and infinitely smaller again. Okay? You understand that? All it is that's all existence is basically a series of spheres getting infinitely smaller and infinitely larger. And they might not necessarily be shaped as spheres either. They might be shaped as eggs and ellipticals, different things like that. You know what I mean? So, but yeah, that's basically how time applies, okay? And like I said before, the strong force and the weak force, they're in gravity and the EM spectrum, they're all the same thing, okay? Because all the electromagnetic spectrum is a series of photons, antiphotons contained within the Higgs, getting infinitely smaller and infinitely larger, okay? That's all it is. It's all the exact same thing whenever you follow the gradiuses of space, okay? They're all the exact same thing. It's beautiful, okay? So, what exactly are dark energy and dark matter, okay? So, dark matter if you take a galaxy, if you take a galaxy, they say that the dark matter is basically what holds the galaxy together, okay? And the dark energy is what separates the galaxies, okay? So think about it like this right now, okay? For instance, I could be considered dark matter and dark energy, okay? Because I'm a conglomeration of photons, antiphotons contained within the infinite Higgs, okay? And I'm pushing energy out at you with my voice and the air that surrounds me, which are both dark matter and dark energy, okay? Basically just dark matter, dark energy. The air is dark matter, dark energy. The wall, this board, everything is dark matter, dark energy, okay? That's all it all is. Whenever you account for the gradiuses of space, it's all basically the same thing, okay? The only difference between, okay, like I said before, the infinite torus, okay? The only difference between what you see here and what you see out in space is that what you see here is an energy field as well, but it's a lot more dense, okay? Because it sounds funny, but you, like I said before, okay, everything within the universe is a universe, okay? You are the universe, okay? This whole universe, here's you, here's the universe. It's all you, okay? You are the universe. I am the universe. And we are the multiverse, okay? Do you understand that? That's how it all works. It's a beautiful thing. You know what I mean? It's it's really deep stuff, but it's a really beautiful thing. So like I was saying before, the electromagnetic spectrum starts at magnetic and love waves, makes its way all the way down to gravity and entropy waves. Okay? So the beginning of the spectrum you could consider white. Okay? And the end of the spectrum you could consider black. Okay? So you have white going to black. And between that you have red, orange, yellow, green, blue, indigo, and violet. Okay? So whenever you're looking at all the colors infinitely, like whenever we're seeing through the air right now, it appears as clear. Okay? That's why seminal fluid, plasma, water, air, all those things are clear. Okay? Because they're infinite. Okay? and we are infinite as well, but our mass and energy is more dense than they are, okay? So we appear as we are, okay? So, I mean, for me to basically do this right now and to move around, I'm moving through an energy field, okay? And for my photons and antiphotons to move through an energy field and to be able to do this so easily, I mean, there is so much physics involved with that. It is intense, okay? Like, for instance, right now, me. The reason you're seeing me right now for is because, like I said, dark matter and energy contained within infinite Higgs is me. On the outside of my Higgs is gravity and entropy waves holding me together. Then from there, photons and antiphotons are shooting out from there, causing you to be able to see me, okay? Which are the gradiuses of space, okay? They kind of look like this. Okay? Because you have kind of like the Higgs here, okay? And they're getting both infinitely smaller and infinitely larger, okay? That's the way that it more or less works. That's how you communicate with people, okay? But whenever you're looking out in the space, either to the ground or to the sky, you're basically looking within yourself, okay? And whenever we talk to each other, whenever we communicate, we're basically looking within each other, okay? But we're also looking outside of each other, okay? So the stuff gets, I mean, it's a beautiful thing, but it does get very complicated, okay? So let's get into black holes, okay? So like I said before, a black hole, if you look at the center of galaxies, you can basically see a black hole, okay? But the issue with it is looking at a black hole is just like looking at a rainbow. It exists, but it's an optical illusion, okay? Because, like, this is the Earth, and this is the Sun, and between them is space. Okay? Which are basically antiphotons, entropy and gravity waves. Okay? So, this entire space is basically antiphotons, gravity, and entropy waves. Okay? But once you start looking at them from a distance, they become more condensed. Hence, why in the center of galaxies a lot of the time you can see black holes, okay? Black holes are just an optical illusion. It's just like rainbows. If you chase after a rainbow, you're never going to catch it. Just like a black hole. If you chase after a black hole, you're never going to catch it because it's an optical illusion, okay? But the thing about it is if you do travel towards a black hole, due to time and everything like that, you're going to be able to travel back in time, okay? So, because relative to somebody back here on the Earth, you're going to be going back in time, okay? Relative to you or somebody that's in the same spacecraft as you, you're going to be in the same time field as each other, you know, relatively, but relative to somebody back on the Earth, you're going to be going back in time, okay? Which I'll get into crop circles in a little bit, but I'm pretty sure that's all that crop circles are, is it's just us from the future trying to communicate with us now to help us wake up. You know what I mean? Because until we wake up and we start to see all this stuff and start to realize it makes sense, people are going to be ignorant, and if us from the future tried to communicate with us from now, too many ignorant people would want to destroy them because they would want to think that, you know, it'd be like the movie Arrival, where, you know, you have smart people that understand if they wanted to destroy us, they already could have, and you have the dumb people that think, oh yeah, well they must be here to kill us. You know, we have to wake up. We have to realize they're trying to communicate with us. Okay, it's because if you go by everything being infinite, I don't think you can travel to other galaxies, because we can see the light from other galaxies, but the only thing that we can see the light from other galaxies for is because the light's traveling towards us from them at an infinite speed. Okay? And that's the only reason why. If you ever tried going to another galaxy from our galaxy, you basically just keep going and going and going and going, and you'd never get closer to it. You know what I mean? Unless you were going faster than infinite speeds. You know what I mean? That's the only way that you would be able to catch up to another galaxy, but I don't know if that's possible or not. But yeah, so pretty much that's the thing about it, is we pretty much have to be contained theoretically within our own galaxy. But I mean, we can travel all around our galaxy. We can travel back in time. You know what I mean? Like, you know, there's, you know, we're not too constrained on this whole thing. So let me get back to you in 1 second, okay? Okay, so if you guys want to watch any of my other videos, you can, to kind of get a little bit more up to date on some of this stuff. A lot of this stuff I have to go over again and different things like that to try to explain things, so it gets kind of convoluted. People just kind of watch my videos, they can get a better grasp of things, but I've went over this before. But so if you start to explain elementary physics, okay, related to the gravities of space, okay, so if you account for the voltage and how large the quarks and leptons are for elementary physics, you'll start to kind of be able to understand more or less kind of how the photons and antiphotons come into play. But so in the center, I'm not going to explain the antiphotons. You can just kind of think of these black lines as the antiphotons, and the photons, what's within them. Okay, but so accounting for voltage here, it starts at the electron neutrino, goes up to the muon neutrino, the electron, up quark, down quark, tau, antineutrino, strange quark, muon, tron quark, tau quark, bottom quark, top quark. Okay, and then if you want to account for antiquarks, you have the electron antineutrino, the muon antineutrino, the positron, the anti-up, anti-down, the You have the anti-top, the anti-bottom, anti-tau, basically just all the antis, okay? But whenever you're applying for elementary physics, you'll find that, like I said before, if you look at this as a whole, it looks like basically a big corridor getting infinitely larger and infinitely smaller, okay? So, like I said before, you are basically the universe. I am the universe. We're the multiverse, okay? So, whenever we look out in space, all we can pretty much see is what's contained within the electron neutrino. Okay? That's all we can see. Okay? All the galaxies, everything that we see with Hubble and stuff like that, the observable universe, it's all contained within the electron neutrino. Okay? Which is basically all space is the conglomeration of antiphotons. Okay? And that's all we're able to see, okay? That's how infinite that space is, okay? This is how far it goes, okay? And this is all contained just within one hydrogen atom, which is also the same thing as a hydrogen photon, okay? But this is all that we can see, is what's within the electron neutrino, which is space, okay? That's how infinite it is. And the better our technology gets, it was just, I mean, I'm sure it was synchronicity. I'm sure there was higher power or something involved that I figured this out whenever we had it just figured out with the right amount of elementary particles that we found. Because if we found more, I don't know if I would have pieced this together or not. But, yeah, I mean, the better our technology gets, the smaller the particles we're going to be able to see. You know, and the better our technology gets with telescopes and stuff like that, the larger the stars in space we're going to be able to see. Okay, because whenever you're looking, because think about it like this: the sun, we're basically on the Earth that's orbiting the sun. The moon is orbiting us, okay? Think of the sun as a photon, okay? And think of our galaxy as an antiphoton, okay? So if we have a little telescope that's orbiting around, you know, I put it around the sun, but we have a little telescope that's orbiting around the Earth. We're not going to be able to see very far, okay? If we're basically on a fundamental particle that's orbiting around a photon, okay? You know, think about how far you're going to be able to see with that. You're not going to be able to see anything. You know what I mean? So it's just, it's completely limited. Okay, so let's get into ego and consciousness, okay? So this is getting to be a little bit more transcendent of a lecture. So ego, what is ego? Ego is the part of you that tells you you're not good enough, or you don't look well, or, you know, just puts you down and different things like that. Consciousness is basically looking at a flower, or, you know, sitting on the beach and listening to the waves of the ocean and just watching the ocean, okay? That's consciousness, okay? So everything is basically a conglomeration of consciousness and ego. Okay? So you can think of the ego is kind of like the antiphoton, and consciousness as the photon. Okay? Everything is basically consciousness. Okay? But you are your ego. Okay? But the trick is to get your ego and your consciousness to be able to get along with one another. Okay? So you can stay balanced. Okay? But like right now, like I said before, like this board, this wall, this air, the light, the plants outside, the animals, it's all within me. Okay? And it's all within you. Okay? So everything at a fundamental level, like looking at it like that, is consciousness. Okay? But you are your ego. Okay? So the trick is to get your ego and your consciousness to get along. Okay? So to be able to do that, the next time you get mad about something or something like that, just realize, oh, that's my ego. You know what I mean? Whenever somebody makes you mad and you want to get them back, just realize that's their ego, that's my ego. I'm not going to let my ego fight with their ego. Okay? And if people start thinking about that and looking at the world like that, then people will be able to be at peace. You understand that? So I just wanted to get into that a little bit. Now, something else I want to talk about is quantum computing. Okay, so with quantum computing, I don't know if we necessarily need quantum computing or not, because it's highly technical. You have to get the processing unit cooled down almost to absolute zero. There's a lot of technicalities involved with it, and I don't know if you necessarily need to do that, because if you basically account for the shells, okay, like the way that God, makes it work for us, which in the way that I think that everything is God. I think that I'm God. I think that you're God. I think that this wall is God. This board is God. Everything is God. Okay, but if we basically apply the way that God does things and the use of shells and different things like that, and we apply that to computer science and basically come up with a new form of mathematics that accounts for the shells, I don't think that you necessarily need quantum computing and you need to cool the processing unit down to absolute zero and different things like that. I think it's too technical. I think if you basically just account for the shells, and just apply that, like for instance, 0 could still be 0, but 10 could be this, 20 could be this, you know what I mean? And it just keep going up and up and up and up. I think if you just basically apply the shells to computer science and engineering, I think that we can probably develop a lot better technology than having to use quantum computing. I don't know that for sure, because if you account for binary, which are basically ones and zeros, that can pretty much kind of like account for the photon and the antiphoton, which would be 1 and -1. You know what I mean? So, but I think if you found a way to account for shells, you could basically just keep going infinitely. You wouldn't have to stop. You know what I mean? So I think quantum computing is over technical. You know, it can be simplified. You know, we can progress a lot better. But anyway, what else was I wanting to talk about? I'll talk about life and death real quick. Like that video that I showed you earlier, basically dealing with the life of a photon and antiphoton contained within the Higgs. You know, that's all it is. Okay, is basically, okay, think of yourself as this photon. Okay, so you basically have, I don't want to draw them in here, but you basically have energy within you, okay, that basically keeps you going. Okay, now to sustain yourself, you have to absorb other photons and antiphotons. Okay, if you don't, you know, you'll die. You have to absorb other photons and antiphotons, which are the air, the light, the water, the food. You know what I mean? Like, to be able to keep yourself sustaining. Okay, perpetuating. But someday, you're most likely going to die, and that energy that keeps you going is going to leave you. Okay? And after that happens, other energies are going to come in, like bacteria, larvae, animals, all kinds of things like that are going to come in and are basically going to help you start to decompose, which, what are they? They're also energy and matter, okay? And so basically they're going to come in and they're going to start working on you, and slowly, after a while, you're going to disappear. And the only part that's going to be left of you, of what you were before, is memories that other people have. Whether it's your family just remembering you, or your friends, or what they've written about you in books, or music that you've made, or whatever way. That's how you're going to be remembered. Okay? But where you were is basically going to be a clear space. Do you understand that? So, where your energy goes, I don't know. I mean, I know the energy of your matter, I know where that goes, but I don't know where your actual self-sustaining energy goes. But if you are the universe and I am the universe and we're the multiverse, means it could pretty much go anywhere. You know what I mean? So, yeah. That's one of the main philosophical questions is, you know, because like I said before, with the crop circles and stuff like that, and us from the future basically trying to communicate with us now that are from the past, do aliens from other galaxies and stuff like that exist? I don't know. And to tell the truth, I don't know if we'll ever know. You know what I mean? Because like I was saying before, technically, theoretically, travel between galaxies, also known as photons and antiphotons contained within the Higgs, is possibly impossible. You know what I mean? So, I don't know. But even if we'll never know that, does it really matter? You know what I mean? Like, because if your energy moves on, you're not going to know anyway. You know what I mean? So, you never know. That might be the way it is. We might go from this galaxy to another galaxy to another galaxy to another galaxy, you know, being a part of totally different alien races each time and never even know it. You know what I mean? Who knows? You know? So, but yeah. I mean, it's all a really beautiful thing. If you want to watch my other videos, I can talk about how basically existence follows the same template, which, you know, it's going back and forth from white to black, black to white, white to black, black to white, nonstop. It's never ending, but plants follow the same template, stars follow the same template, animals, people, we all follow the same template, okay? And I talk about that in my other videos, but I don't want to make too long of a video today. But yeah, that's pretty much it. The easiest way I can explain it is everything is the infinite torus, which is the photon, the antiphoton, all contained within the Higgs, okay? And it's all infinite, okay? It's all infinite. It's all shooting out. Shooting in. Photons, antiphotons, contained within the Higgs. You know what I mean? It's a really beautiful thing. I mean, at the most fundamental level for me to explain it is just to say it's a series of spheres getting infinitely smaller and infinitely larger, with magnetic waves, also known as love waves, being infinitely consumed by gravity and entropy waves. And the gravity and entropy waves basically crapping back out the magnetic and love waves just like we do. You know what I mean? So that's all we're doing. Basically absorbing, reflecting and emitting. You know what I mean? Eating, being, and crapping, and having sex. You know what I mean? That's all it is. It's all the same thing. You know what I mean? So if you have any questions or anything like that, just leave a comment in the comments. You know, the stuff is on the fundamental level. Whenever you try to explain it, it's understandable, but it's still, once you start to delve into it and you get into the EM spectrum and gravity and the weak force, strong force, all that stuff like that, it gets more difficult to explain to people on the fundamental level, okay? But that's all it is. Photons, antiphotons, contained within the Higgs, which are all beyond infinite. Fields of time, gradiuses, all beyond infinite. You're beyond infinite. I'm beyond infinite. It's a beautiful thing, because something that has no beginning and no end is infinity. Something that has no beginning, no end, an end, and a beginning is beyond infinity. So, okay? That's all it is, though. So, all right. Thank you. I appreciate your time.
Okay, so I just wanted to show a little bit of information relating the crop circles. So, you know, of course, some crop circles could possibly be due to, you know, some over-imaginative farmer, you know, but I really do think that crop circles are basically most likely us from the future trying to communicate with us now to basically try to get us to wake up so they can basically become, you know, basically reintegrated in with our culture, because I'm sure they're probably in our culture now, probably just regular everyday looking people, but they're actually people that are from the future. But so if you look at some of these crop circles, you start to see that they look, kind of like something that can be related to the gradises of space. You know what I mean? But it's just, you have to be able to start to kind of see the patterns with it all. Like this kind of looks like a, jellyfish, dealing with the, infinite torus, and, just applying the, photons, antiphotons contained within the Higgs. You can kind of see a little bit of how they're trying to communicate. You know what I mean? So, all this is possibly just, theoretical, and I'm being over imaginative, but, I think it kind of makes sense, to an extent, because, if you're trying to get people to wake up, you got to try to show it to them somehow. With this, you can see, basically kind of like the infinite torus, basically more or less like the yin and yang, the photons, the antiphotons, all kind of interrelated. But it's just kind of food for thought that it's most likely us from the future trying to communicate, with ourselves, trying to get us to basically wake up so they can reintegrate back in with us, you know what I mean? And I'm sure once that happens, if it does, that we will progress exponentially faster. So anyway, I just wanted to show you all that. All right, thank you.